Okay, guys. 3.2, rotations and symmetry. We know what rotations are. We just did those in Desmos. It's awesome. I'm not making you write these in either. This is just here as a review if you need it, okay? So a rotation is when we turn it about a fixed point, and it'll always say where we're turning. The fixed point is called the center of rotation, so that's our focal point when we're doing the rotation. An angle of rotation can mean rotate 30 degrees, rotate 90 degrees, rotate 270 degrees, okay? The angle formed by the rays drawn from the center of rotation to the original point. So we'll draw those in a minute. And rotational symmetry. A figure on a plane has rotational symmetry if it can be mapped onto itself. So that means mapped onto itself, it looks exactly the same. Okay? So after we rotate it, it looks exactly the same. With an angle of rotation, it must be 180 or less, and we're going to talk quite a bit about that in a second. Okay? That is also called point symmetry. So, on a quiz, on a test, on the SOL, the question will say, does the figure have point symmetry? All that means is if we can rotate it 180 or less, and it is the exact same, then yes. So let's talk about that. A rotation is any guess what word I'm about to write? Oh my gosh, isometry! I said that, it sounded so like southern for some reason. I don't know why. Alright, there we go. Okay. Let's start with the actual point that we have, and I'm going to teach you a trick. You know how some of you guys were really good at the lines of symmetry, and some weren't? It's usually the opposite for this. The kids that kind of struggle with lines of symmetry are really on it with rotations. So let's see what happens here. Let's name this point. It is 5, 3. So let's put it there. I'll give you a second to catch me. Okay. Let's talk about a couple things. If I go this way in a rotation, that is counterclockwise. Do I need to write that word, or are we okay? If I go this way on a rotation, that is simply clockwise. We're going to do both in just a second. Alright, let's say that I tell you to rotate this point 90 degrees clockwise. A really easy way to do it is to literally move your paper and find the new point. So watch. If this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. When I do a rotation, I can treat the quadrants as different quadrants. If I'm rotating 90 degrees, what is a full circle? 360. So 90 degrees is one turn. 180 would be 2 turns. 270, 3 turns. And 360, the 4th turn, right? So if I'm going 90 clockwise, I'm going to turn it once. This is now quadrant 4. And I can determine where this point lives. It lives at 3, -5. So I go back and I write that. Whoa, we can literally turn the paper to determine where the new point would be. Isn't that cool? That is a trick. There's rules to this that we can memorize as well, but you know I'm a big fan of actually understanding instead of just memorizing the rule. So obviously the rule for a 90 degrees clockwise is xy becomes y -x. That's the rule. So sometimes it's better to find the point and then determine the rule than to memorize a bunch of rules. Okay? Alright, let's say I'm going to take this exact same point, but I'm going to go counterclockwise 180 degrees. How many turns would that be? 2. So I'm going to take my point. I'm turning it once. It is now in quadrant 2. I'm going to turn it again, so now it's in quadrant 3. So let's determine what that new coordinate point would be. It would be -5 now, -3. So I go back and I write it in. -5, -3. Whoa! So a rotation of 180 goes from xy to -x, -y. That's it. Okay, I'm going to get another color because I'm going to give you your challenge. Ready? Ready? I want you to rotate our green point, minus green, counterclockwise 270. So how many turns would that be? 3. So take this point, rotate it 270, and find our new point. So now it is at -3, +5. So I ignore what the numbers say, and I read them as what they were. Yay! Does it? Are you being facetious? Oh no, I was really excited.
It makes sense, but I'm not.
But were you really good at the lines of symmetry? And now you're struggling with this? That's I promise you, every year that's how it works out. Every year. If you're really good at both, wonderful. Okay. The last little thing I want to talk about, guys, is we can also rotate negative. So anytime we do a rotation this direction, if I said a 90-degree rotation clockwise, we can say that. I could say a 270-degree, I'm sorry, I said clockwise, a 270-degree rotation counterclockwise. So to get from here to here would be 270 degrees counterclockwise, which is the exact same thing as -90 degrees. Because going this way means we're going negative. So sometimes we talk in clockwise, counterclockwise. Sometimes we talk in angles versus negative angles. Okay? Awesome. Same. Now, that is trigonometry. You are not required to know negative angles in geometry. But on the county assessment, when I was previewing it, they put a negative angle on there for you guys. And I said, I accept your challenge, county. I will teach my kids that, and they will know it. So there you go. It's just those performance matters things that we have to take every now and then. Yeah. I've never made it a quiz or a test. I think I made it a classwork grade, so it was a formative. Yeah, it's fine. Yeah. Okay, let's talk about these. When rotating about the origin, so that's what we did with all of these. 90 degrees counterclockwise, so 5, 3, 90 degrees counterclockwise becomes -3, 5, so write that one in. So we're not going to turn the paper anymore, we're just going to look at what we filled in. 270 degrees counterclockwise, so from here we go 90, 180, 270, becomes 3, -5. Got it? And then 180 degrees is just 2 turns -5, -3. Rotations. Alright, turn the page. And she snuck it in. We're about to talk about angles right about now. Yeah, let's talk about angles. Okay, just a quick review. We already said this. I'm going to say it one more time. A figure has rotational symmetry if a turn around a point, whatever point, of 180 degrees or less. So we said that on the first page, and then we did other stuff, and now we're bringing it back. We got to understand what that means. Here's a tip and a trick that'll help you get this right every time. Figures with rotational symmetry include all regular polygons. So any polygon that you're given that's regular. What the heck does regular mean? Yes, all the sides are congruent. So this is a regular triangle, and all the angles are congruent. So you don't have to worry about turning your paper, imagining anything. If you know that it is a regular polygon, then the answer is yes when they say, does it have rotational symmetry? Okay? And this is just an example of as we turn it, it's going to continuously map upon itself. Alright, here's the one where we get to talk about angles. Angles. Alright. Does the figure have rotational symmetry? If so, to describe the rotations on the map. So watch. If I turn this one 90 degrees, will it be the same? If I turn it 180, will it be the same? No, then we're done. We don't have to go any further. No. No rotational symmetry. This one. If I take this and I literally turn it 90, is it the same?
Yes.
Nope. If I turn it 90.
No.
If I turn it 180 though. Yes. So it does have rotational symmetry, but only at 180. Okay, I'm going to show you how to do C, and then you're going to do D, okay? A regular hexagon. Only at 180 or less. So, I'm going to half the figure. Because we know this has rotational symmetry because it's a regular hexagon. But the question says describe the rotation. So they want to know at which angle degrees does it have rotational symmetry. So watch. What would each one of these angles equal? What is 180 divided by 3? 60, 60, 60. So, yes, here's the trick. Don't just write 60, 60, 60. If I turned it 60 degrees, if I turned it 120 degrees, and what would be my last one? 180. Good job. 180 or less. Right? Alright, actually I'm going to do D with you and I'll let you do E. If you want to do it, go ahead. D. Always think of everything as a full circle. I'm going to draw the other ones in, but I only need to worry about half of the circle, as we know. But I'm going to draw the other angles in that would be formed by this full circle in the middle. Okay? So from every vertex of the polygon, no matter what the polygon is, we draw a line to the center. Can I now figure out each degree measure in here? Yeah, what would I divide 360 by for this one? 5. And what would that be? What is 360 divided by 5? 72, that's right. Oh. I only wrote 2 of them because I can't go above 180. So can you tell me the 2 degrees? There we go.
Great word.
All right, E and F, answer it, and we'll be done. E and F. See if you can do E and F. Wait, is this guy regular? No, so I'm not going to draw to every vertex because this guy is not regular. But if I took this and I turned it 90, would it be the same? If I turned it 120, would it be the same? But if I turned it 180? Yeah. Yes, at 90. And yes, at 180.
Yes, amigo,
And then what about F? Could I rotate that guy ever and end up exactly the same?
No.
Nope. So does it have rotational symmetry? All right, we are done, guys. You know what your homework is.